and force in the downward direction is going to be negative. All right, so we'll take a look at 3 cases. We'll have 3 different cases regarding work. Okay, so you may have an object moving along the x direction just like that. I think I'm just going to keep the same direction. All right, so let's set up 3 cases. All right, so in the first case, there's going to be a force in the same direction, along the x direction, along the direction of the motion. In the second case, the force is going to oppose the motion. In the third case, the force is going to be 90 degrees to motion, along the y direction. All right, so we got 3 cases. Forces in the same direction of motion. Force is opposing motion. Motion is in the forward direction. Motion is in the forward direction, and that force is at 90 degrees to motion. So this one is going to be 90 degrees. Okay. Now let's take a look at work. Force is in the positive x direction. Motion is also in the positive x direction, which means that the work is going to be positive. Which means that the energy is going to be gained. Okay, I guess the energy is gained. That's what it means. So the energy gets transferred to the mass, so the mass is going to end up gaining energy in this case. So when the work is positive, the energy is gained. Okay. In this case, notice that the force is opposing motion, right? So force is along the x direction, negative x direction. Motion is along the positive x direction. So you have negative times positive. So this is going to be negative work. So which means that the energy is going to be lost. All right, so here the energy is gained. All right, here the energy is lost. Okay, guys, when we say energy is gained, energy is lost by the mass. Just remember. Because you're applying a force on the mass, so the energy is going to get transferred to the mass. You're applying a force on the mass, so the energy is going to be taken away from the mass. So, which means that the mass is the one that's going to end up losing the energy. All right, so in this case, the amount of work done is a positive, negative, or no work. All right, so the force is along the positive y direction, and displacement is along the positive x direction. Okay, so what do you guys think? This is, in this case, the work is it going to be positive, negative, or no work? What do you guys think?
Since there is still displacement, I think work is still being done.
Okay, I'll give you 5 points for saying something. So the work, is it going to be positive, is it going to be negative, or is it going to be no work? Okay, guys, there's displacement, but there's certainly displacement in this direction. But not because of this force, right? This force does not have a component along this direction. This force is not responsible for this displacement. All right, so displacement can happen because a moving object may stay in motion. It doesn't need to have a force. That's called inertia, right? And certainly this force is not responsible for it because this force doesn't have a component along the direction of motion. So if that's the case, the work is going to be 0. All right, so no energy is being transferred. If that's the case, the work is going to be 0. All right, so no energy is being transferred. All right, so no energy is transferred in this case. So we can have positive work, you can have negative work, you can have no work. Okay. If the force is along the direction of motion, work is always positive. So the object is going to gain energy. If force is opposing motion, the work is always negative, which means that the object is going to lose energy. If force does not have a component along the direction of motion, no work is being done. No energy is being transferred. All right, so some real life cases. And so lifting something up, in this case, a cat. All right, so notice that the force and displacement are in the same direction. So the positive work is being done on the cat. What that means is the cat is getting energy. That's what it means. So the cat is getting energy. By lifting a cat up, we energize the cat in essence. That's what it means. If you are carrying a cat forward from one place to another, all right, the work done on the cat is going to be 0, but let me just clarify that because it's a little bit confusing. If you're moving in a straight line at a constant speed, and if the amount of force that you apply to the cat, so this is the applied force, if this force is there to balance the weight of the cat and nothing else, all right, because of the simple reason that by virtue of the fact this force has no component along the direction of motion, this force is not going to transfer any energy to the cat. So this force does not transfer. It doesn't transfer any force. It doesn't transfer any energy to the cat. That's what it means. So which means that there's no work being done on this cat by this force. So no energy is being transferred to this cat by this force. That's what it means. Once again, you're moving a straight line at a constant speed, and the force that you're applying has no component along the direction of motion, which means that no energy is being transferred to the cat by that force. So no work is being done. Okay, so if you're lowering the cat down, notice that the force is there to balance the weight of the cat, and the motion is in the opposite direction. So in essence, the force opposes the motion itself. So in that case, negative work is being done on the cat, which means that the cat is losing energy. When you lower the cat down, the cat is losing energy. You're taking energy away from the cat. When you lift the cat up, you're energizing the cat. When you're putting the cat down, you're taking that energy away, in essence. But now it gets kind of weird.
Strongest
Because part of it you will get immediately. So we'll just go with the definitions for now.
man. And this is what all the fuss is about. The Husserl stone weighs 410 pounds. That's about the size of a...
So this thing is 410 pounds. Okay, so he lifted up, applied a force on it. And then stone moved in the direction of the force, right? So which means that he was able to transfer energy to the stone. So the stone is energy.
And Greg Ernst has been looking forward to this event for a long time. Legend would have us believe that...
Okay, now he lifted the stone, which means that he transferred energy to the stone. He did some work on the stone. The amount of work that he had done, he transferred energy to the stone.
This stone comes...
Now he's carrying the stone in the forward direction. Okay, now just go with me. I'm going to make a few assumptions here. So just go along with the assumptions. They're not 100% accurate, but they're accurate enough for the sort of physics that we're doing here. Imagine that he's moving at a constant speed in a straight line. He's carrying a stone which is 410 pounds.
From a sheep pen and was carried around a circular course. The farthest distance it was carried was about 60 meters, not by the shepherd, but by his daughter. Just imagine James Perry sitting on your chest. That's the pressure Greg is feeling at the moment.
Okay, now notice that he's getting tired, right?
Difficulty in looking to see where he's going over the top, but the grip...
I mean, he slowed down a little bit. Look at the face.
Looks solid.
He's gasping for air. I mean, he's doing the fish mouth thing. He's getting tired. Yes, he's getting tired. He's carrying something which is 410 pounds. Here's a question for you. Why would he, number one, how much work is he doing on the stone? Okay, so provided, with the assumption that he's moving in a straight line at a constant speed, what is the amount of work that he's doing on the stone? Okay, he's applying just enough force on the stone to balance its weight. Okay, that's it, as he's moving horizontally at a constant speed. So how much work is being done on the stone when he's actually carrying the stone? Okay, so by definition, he's not doing any work on the stone, right? The amount of work done on the stone is going to be zero because the amount of force that he's applying on the stone, imagine the weight of the stone, that's 410 pounds. But in the direction of motion, there's no force in that direction. It's just maintaining his initial motion. No work is being done on the stone. So why is he getting tired if he's not doing any work on the stone? Why is it that the physics is not working out? Or is it? Okay, guys, this is the sort of stuff you will have on the test next week. So he's carrying a stone, 410 pound stone. He's moving in a straight line at constant speed. And according to physics, he's not doing any work on the stone, which means that he's not transferring any energy to the stone yet. Clearly, this guy's getting tired. Why is he getting tired? What do you guys think? I'll give you 20 points. I'll just whatever you guys are thinking. Just either put it on chat, say something. Stone does work on him. Okay, Lucy, I'm gonna give you 5 points. No, stone does not work on him because the stone has gravity acting on. Gravity is pulling. Gravity is a force in the downward direction. So the motion is 90 degrees to it. Okay. Corona. Okay, I'll give you 5 points. The legs are doing the work. Okay. There's something about the legs. We need to focus on that. I need more gravity on him. Okay, Isla, that's also correct, but I need more. So I'm gonna give you 5. Okay, the legs, more gravity. I need more.
Does it have something to do with the increased inertia from carrying the stone?
Okay, I'll give you 5 points. You guys are getting close. Okay, so the reason why you guys are struggling a little bit is because it's a new concept, right? Okay, gravitational potential. We haven't talked about it, so I'm gonna give you 5 points. It's not really related to that either. Okay, guys, what's the definition of work? Number one, this guy is getting tired, which means that he's losing energy, right? All right, so which means that negative work is being done on him. Okay, his body is moving in the forward direction, and there is a force acting on him, opposing in the opposite direction of his motion. Okay, so what is that force? Guys, remember, when this guy is walking, he's applying a force on the ground, right, in the opposite direction of his motion through friction. So he applies a force. Now, obviously, because of the stone, his apparent weight went up quite a bit. So which means that the amount of friction that he's applying is going to be much larger. So he applies that force in the backward direction. That's the applied force through his muscles. He applies a force in the backward direction, and then his body moves in the forward direction. So the applied force is in the backward direction, and the motion is in the forward direction. So the negative work is being done on it. All right, so this guy is losing a lot of energy. He's not transferring any of the energy to the stone, but he's applying a force on the ground. So which means that he's actually transferring force to the earth. He's transferring the energy to the earth by just walking. So the energy is leaving his body. It's just going to the earth in essence. All right, that's what it means. So the negative work is being done on his body because of it. So through friction, he applies the force in the backward direction. His body moves in the forward direction. So the applied force is in the backward direction applied to the earth, and his motion is in the forward direction, in the opposite direction of the motion. So the negative work is being done on. Okay, that's part of the reason if you are trying to remain fit, or if you want to lose weight, the way to do it is obviously you have to expend energy. You have to literally you have to transfer the energy out of your body in essence. Okay, one of the best ways to lose weight obviously is running, because you apply a force on the ground in the opposite direction of your motion, or by walking. And when you drive, again, you do the same thing. The tires will apply a force on the ground in the opposite direction of the motion. As a result, the car ends up losing energy in the form of, obviously, you start to run out of gas at some point. So that's what happens. Okay, so no work is being done on the stone, which means that he's not transferring any energy to the stone, but this guy's losing tremendous amount of energy because he's doing work on the ground. He applies a force on the ground in the opposite direction of his motion. As a result, there's negative work being done on it. All right, so gravity extends all the way out to the moon, right? We discussed that many times over. All right, so here's a question for you. If gravity extends all the way out to the moon, how much energy is being transferred to the moon by the force of gravity? How much energy gets transferred to the moon by the force of gravity? What do you guys think? How much work is being done on the moon? How much energy is being transferred to the moon? All right, so I'm going to give you 20 points for anyone who can guess this, who can come up with the best answer. So what's the amount of work done on the moon? What's the amount of energy transferred to the moon? What do you guys think? Because we know gravity extends out to the moon, right? So how much energy is being transferred? What's gravitational force times the moon's mass? I'll give you 5 points. No. All right. How much work is being done on the moon by Earth's gravity?
So the moon moves straight ahead. The Earth's gravity pulls down the moon. So like at each instant, it feels like if the moon's moving straight forward, the Earth's pull is like it's like it's moving vertically, whereas the moon's moving horizontally. So those don't match up with each other. They don't overlap.
Okay, so what you're saying is
no work is being done.
No work is being done. 20 points. Absolutely. Okay, guys, the motion is horizontal, right? The force is 90 degrees to motion. So which means that this force is not responsible for that motion. No work is being done. No energy is being transferred to the moon. So gravity from the Earth absolutely does not contribute to the moon's motion. It does not transfer any energy to the motion of the moon. All right, so that's what it means. No work is being done because of the fact that the force is 90 degrees to the motion itself. So pick out the best answer, put it on the chat. Where was he when the audience rocket? Who's on right? Where was the number? 5, right? And here LA. What else? What else? Right, that's my question. Who is the author of them? Okay, very good. C is the best answer. Absolutely. Give yourselves 10 points for those of you guys who pick C. C is the best answer. Okay, so the next question: who expands more energy? Which one is more difficult to lift? Lifting something which is 500 pounds, or lifting something which is 6,000 pounds? Okay, so which one is more difficult? All right, so before we do that, okay, so let's utilize this formula. You want to make your point.